This is Chad Houston. We're doing a flipped assignment. A lot of people have been asking questions on molarity and dilution problems. So we thought we'd take a quick look at the problem of the day. Okay, so first of all, if we look at this problem, one of the things that you'll notice is in almost every problem with dilution problems, they're really talking about two solutions. So in this case, there is the stock solution, which we have. And the stock solution, I've tried, and in this case, so what we first did is to identify the two. So we have the stock solution, which will be in black. And then we have the dilute solution, which in this case is going to be everything in red. Okay, and it's important to think in your mind on a large scale what's occurring. We're taking in some way, shape, or form one solution that's more concentrated, which again is our stock, and then we're pouring a portion of that into a second container, adding water and making that less concentrated. The symbols and the numbers must correspond to that. Okay, so let's first talk about everything we know about the stock solution. So step number one, we just said, look, let's figure out everything we can about this, and we said of our stock, it's very concentrated. It's 65.5 milliliters of HCl. So in the stock down here, we said let's put down everything we know, 65.5 milliliters. Or what I immediately did was to transfer that to 0.0655 liters. And the reason I did it to 0.0665 liters is because what we're going to find out is that in every time, if you look at this portion right here, molarity is not one number. It is two numbers disguised as one number, and the denominator is always liters. So this is just the volume in liters, and currently that's all we know so far about the stock solution. Now let's take a minute to look at the dilute solution. Okay. So if we look now at the diluted solution, let's see what information we can get from that. For the diluted solution, I apologize for this part. We have it says that we're going to make up 450 milliliters. So we got the 450 milliliters of this, and again, molarity is always moles per liter, so I went ahead and said 0.450 liters. Okay, and the other part it gave us is that we want a 0.675 molarity of this HCl dilution. Now what that means is that's not one number, that actually gives us two numbers. That means that it has to be 0.675 moles in 1 liter. Okay, so we actually get two numbers from that, and that'll be kind of important. So what is it that we're trying to find? Well, what we're trying to find is the molarity of the stock solution. So in that case, I'm going to go over here and say let's clearly identify the unknown, and if I clearly identify the unknown, the identification of the unknown is molarity. This is what we're trying to solve for. Okay, so how do we break this apart? Well, let's figure out everything we know about the dilute solution. We know that there's 4.450 liters of a 0.675 moles per 1 liter, so I can find out the number of moles that I actually put in. I can find out the number of moles that I actually put in here. Where did that number of moles come from? It came from our stock. So let's follow along and see how this works. I can say 0.450 liters, okay, times 0.675 moles of my HCl per 1 liter. Liters and liters cancel, okay, and typically what I get, if I work this out, I end up getting that. I end up getting 0.450 times 0.675 is going to equal about 0.304 moles of HCl. So what the person did is they took 0.304 moles of HCl from a stock solution now. So we could also put this in black because that's kind of where it came from. Okay, they put that in a stock solution. Okay, they poured it in a beaker, and then what they did is they added enough water to get up to 450 milliliters. Okay, to make my 0.675 molarity dilute solution. So where did this come from? This came from over here. That's where it came from. So now over here, we know that if we take the 0.304 moles of HCl, that came from my stock, and we also know that it came from a volume of 0.0655 liters, because that's how much they said that we used. We can now find the moles per liter. And if I solve for that, 0.0655, my answer is that it's about 4.64 moles of HCl for every 1 liter, or 4.64 molarity of this HCl. Now let's stop and ask ourselves, does that make sense? Okay, what we're saying is we took a small amount of a very concentrated HCl solution that is less than 100 milliliters, about half that. We poured it into a beaker, added some water up to about a half a liter, okay, and then it's less, the concentration is much less. How much less? Well, 0.675 moles per every 1 liter. So yes, that does make sense, and that would be a reasonable answer.